Hi there, math lovers, and welcome to another video by our channel. Today we have selected what is, in my opinion, a very beautiful question from Argentina Math Olympiad of 2007 for high school students, and with a request as follows. It is a number theory problem, so the problem statement is like this. Find all prime numbers p and q such that p squared plus q is equal to 37q squared plus p. Initially, this problem might seem quite a complicated problem, but we will try to break down together step by step the solution to this problem, always but what I suppose to be very elementary solution and accessible to anyone without special knowledges in the field of mathematics. So, as always, I have covered the solution only to go through it step by step together and to better try and understand what we have brought forward here. So first of all, as always, we will start with some simple observations. And in this problem, we say that P cannot be equal to Q, because if P is equal to Q, we would have the P squared plus P is equal to 37P squared plus P, or if we do the math, that would be 36p squared equal to 0. So p would be equal to 0, which clearly does not satisfy the request of this problem. So what we should do with this problem and the form of the given equation is that we should express it in another form. So from the given form, p squared plus q equal to 37q squared plus p, we take the p on the right hand side and we bring it on the left hand side, and we do the same thing with the expression of q, and we will get p squared minus p is equal to q times 37q minus 1, because we have factorized q after bringing this q on the right side of the equation. In this case, what we do is that we divide both sides of this equation with q. We can do something like that because q is a natural number different from 0. So on the left hand side we factorize p, and we have p times p minus pi minus 1 divided by q, and on the right hand side q is simplified with the q, so we have 37q minus 1. We call this equation number 1. So our reasoning goes as follows. Since in this equation number 1, since the right hand side is a natural number, also the left hand side must also be a natural number. But q in this left hand side cannot divide p, because p and q are both prime numbers and they are not divisible by themselves. So in this case, in order for also the left hand side to be a natural number, q must divide p minus 1. So we deduct that q divides p minus 1. This means that when we divide p minus 1 with q, there exists a natural number k such that p minus 1 divided per q is equal to k. So if we do some simple math on this side, we will have that p minus 1 is equal to k times q, which brings that p is equal to q times k, k times q plus 1. So with this new expression that we just got, we make the substitution of the value of p on the equation number 1 that we have selected up here. And we will have, that p minus 1 divided per q is equal to k, that we just assumed up here, while p is equal to k q plus 1. So k, which multiplies k times q plus 1, is equal to 37q minus 1. So this is another expression of the equation number 1 that we have up here. If we do the factorization and the math on this expression, we will have that k squared times q plus k is equal to 37q minus 1. Or if we take, let's say, all the factors which contain q on the right hand side, and we leave the other factors on the left hand side, we will have k plus 1 is equal to q, which multiplies 37 minus k squared. We will call this the equation number 2. Then, in this equation number 2, we see that the left-hand side is a natural number, because k plus 1, k is a natural number, so k plus 1 will also be a natural number. This means that also the right-hand side must be a natural number, which is a positive number, of course. So, in order for the right-hand side to be a positive number, 37 minus k squared should be greater than 0, which means that k squared should be smaller or equal to 37. This is only true for k natural numbers which are smaller or equal to 6. So we here deducted a very important result, which we will use later, and which is that k is smaller or equal to 6. We will call this the equation number 3. We go on with our reasoning toward the solution of this problem, and we go back to the expression of the equation number 2. Now we divide both sides with 37 minus k squared. So we will have k plus 1 divided by 37 minus k squared is equal to q, because this expression will simplify with the expression that we are dividing the equation. So, since the left-hand side of this new equation that we got on here is a natural number, which is q, also the right-hand side will be a natural number. So k plus 1 divided for 37 minus k squared will be a natural number. So this means that k plus 1 divided per 37 minus k squared will be greater or equal to 1. So if we do the math, we have that k plus 1 is greater or equal to 37 minus k squared, or k squared plus k minus 37 will be equal or greater to 0. But this inequality is only fulfilled when k is greater or equal to 6. Because if k is 5, let's say, the expression, the value of this expression will be a negative value, which is not greater or equal to 0. So this inequality is only fulfilled if k is equal or greater than 6. We will call this the fourth equation. But now we have two conditions from the third equation, where we find that k is smaller or equal than 6, and on the fourth equation we have that k is greater or equal to 6. This only means that the only possible value that k can take from these two equations, we deduct that the only possible value is k equal to 6. So, by returning to the equation number 2 up here, and we substitute the value of k equal to 6, we find that q is equal to 7, which is the left-hand side, divided by 37 minus 6 squared, which is 1, and we find that q is equal to 7. 7 is indeed a prime number. Then we go on the equation up here, because we have that p is of the form k times q plus 1, and we will make the substitutions of k equal to 6 and q equal to 7, and we will find that p is equal to 43, which indeed is a prime number. So we found that the only possible solutions of this initial equation are the prime numbers p equal to q equal to 7 and p equal to 43. These are the only possible solutions of this equation on the set of prime numbers. As always, if you like this solution, please don't forget to like, comment and subscribe to our channel in order for us to be able to bring forward other interesting problems from mathematical Olympiads around the world. Up to then, thank you and goodbye.